Welcome to an OnRamps Physics 2 Optics demonstration. Today I have a concave mirror, so we call that a positive focal length mirror or a converging mirror. So light that comes in parallel will converge at a focal point in front of that mirror. And then it will image things differently depending upon the location of the object. So let's take a look. When an object is close to a concave mirror, the image you can see forms it forms an upright image. The light bulb is right up, and that image is actually, and it's somewhat larger than the object, and that image is actually behind the mirror. If you tilt your head side to side, or we give it a little chance to view it by parallax, you can see that the image probably is somewhere back here. As we move the light bulb away from the mirror, that image will stay back there. Actually, it'll get larger. And then once we cross the focal point, that image will be at infinity, or in actuality coming in from positive infinity. And we're gonna look for it over on that wall. So I'm gonna take this outside the focal point. There's that virtual image getting large behind the mirror. And then we're gonna send it off to infinity and bring it in from infinity on the other side and look for it on the wall. So let's dim the lights so we can see and take a look for this image. All right, as I get it close, somewhere close to the focal point, it's forming an image far away. And one of the first things you can see, or possibly you might be able to see, is that that image is upside down, that the coils of that filament, the loops parts are on the bottom, whereas in the actual light bulb, the loops are on the top. Of course, we could move that image further. If we move this light bulb further out from the focal point, we would see that image moving in closer. And then eventually, when this light bulb is quite far out, the image will be back here close to the mirror.